So I noticed that the presentation screen here sets a different title than the one I have here. So it originally said X things I wish I knew when I started out. So I kind of transitioned into this one, but it's kind of the same thing. A lot of these things are things I wish I knew when I was starting out. Also, maybe a quick thing. I know I'm on Fronteers, but this is kind of a backend talk. So, yeah, sorry about that. But I think a lot of things will transition pretty well, and I'll explain every ugly PHP code that will appear on the screen. So, okay, starting out. This is me. Yes, I used to look like a Greek god with long hair. Not anymore. People grow up, I'm afraid. In the office, they tend to call me the golden god of front-end development. That might be a bit in jest, because I have no idea how actually what a React is, or actually what is CSS still a thing? I assume so. So yeah, that might not be so yeah. The last design and front-end stuff I did was at here, actually. I'm a graduate of interactive multimedia design, as you can see. I'm a graphical master. I work at a company called Made with Love. We tend to do a lot of refactoring and project rescue of big applications, where we try to get applications back on the rails and see how we can support these companies in getting their stuff back in line. So yeah, that was my huge long introduction. Sorry that's so long. Normally I don't talk that much about myself, but okay. Click. Okay, anyone know what this is? That's an airplane, yeah. Okay, we got some experts. So that's a Douglas DC-3. You might have seen it before. It's featured in Indiana Jones. Pretty cool movie. It's made in 1935. And the fun thing about it, it's still operational. People still use this plane. They use it for good transport. As you can see here, this is a post-transport thing. They use it in the military. They still use it as passenger ships, more for luxury passenger stuff, but still, they still use it. And it has its own Wikipedia list, categorized per year with accidents, incidents, and failures. It's like huge, but they still use it today. The fun thing about it, the reason they still use it, is because it's all the pilots love to fly it. It's super agile. It's a real nice plane to fly, and the thing is, everything about it is standardized. It's been through so many revisions that everything is just so streamlined and everything is so great that they still use it. It's a plane from more than 70 years old. It's insane. So yeah, there's some hidden value here behind this plane. Another thing you might be somewhat familiar with, obviously Facebook. In 2007, Facebook had an embarrassing story. So users refreshed the page to check out on the Farmville and stuff, and they saw not their regular homepage, but they saw the source code of Facebook. And that source code wasn't very pretty. It was extremely ugly. Normally I would like show it, but it's kind of illegal to show it because laws and stuff. But if you do a quick search on GitHub, you'll find it very easily. It's pretty out there. Again, this is a bit backendy, but the first 15 lines were just includes of other lines, of other pieces of code, which is not the best. Probably not the best. It's like, yeah, no classes, just plain PHP. Now again, this was in 2007, so cut them some slack. But the thing is, Facebook, you might have noticed, but it's still around. It's been rewritten, obviously. It's been rewritten countless times, but they even forked the programming language. So its original was written in PHP. Then they took PHP, made their own programming language, and that still can execute PHP, but also the new language, and try to merge it that way. Now you might think by yourself, oh, why not just rewrite it? How hard can it be, right? But that's a common pitfall a lot of people fall into. The thing about these pieces of code and that airplane is that they have a lot of intrinsic value. The thing about it is like, there's a lot of meetings, a lot of processes, a lot of things put into it, that it's just extremely valuable software and airplane. So the big thing to take away here is that there's all this code and value in these applications. So it's not a great idea to like just throwing away and just classify them as legacy software and just forget about it and rewrite everything. So, okay. This talk is obviously about legacy software and legacy code bases. And the main idea is that you're a developer and they tend to throw you into this project and say, okay, you're now going to work on this old school application which has a lot of value in it. So how are you going to find your way here? So how do you get started with this stuff? The first thing you need to remember about working in legacy software is you need to kind of a mentality change here. As we covered before, don't rewrite. Don't just automatically think about rewriting what you're seeing. That goes about a lot of software stuff, not only legacy code bases. Don't immediately try to rewrite something. Try and see the value in the code or the application or product that's already there and try to adapt it to something you can find your own value out of. Try to make some mutations to what you want to achieve. Okay. Does anyone know who made this quote? It's kind of a famous one. You can shout it out. You can win a goodie bag. No? No. It's a guy that never worked on legacy code. Originally, it was Mark Zuckerberg again. This is an idea that lives with a lot of young and a lot of Silicon Valley developers. Move fast, break things, just go forward and don't care about anything. It's actually, I think, one of the worst advices I've ever heard in my life about software development. Try to, I know it's normally about agile development and continuous delivery and development and all those stuff. But a lot of people try to make this mindset their own in software development, which is, I don't think, a great thing. You need to take a minute before you start working on software. Slow down. Just have a meeting. Meetings aren't always fun, but they can be fun. Try to create an action plan before you actually start working on something. And then you can always come back to it, and then you can always adapt your vision to new ideas, but don't start just rushing in. Start just with an action plan. How are you going to attack your current problem? Another thing about legacy code and code in general is it's a nice idea to treat it as open source. So that includes documenting everything, because the people that's sitting next to you, you can tell them what this code is all about, but you won't be able to do that in 5 years, 10 years, 20 years if your code is still around, which is a good thing, I think. So document everything. Try to make it as low, the barrier to jump into the code as low as possible. It means setup, all the migrations, database seeding, all those things. Try to make that as easy as possible, and obviously do it in English, because you write code in English. So if everyone else wants to hop onto it, they can from around the world, and there's a lot of talent in the world. That kind of links into this one. So try to automate and analyze everything. Automation is really powerful. If you're ready with a piece of code, don't just do all your tests yourself. Don't just manually go through your entire application, because you're going to lose a lot of time and you're going to do it constantly. So try to find some kind of build process that can be a compile process, or npm build or something like that. Just kind of showing my non-knowledge of front-end stuff here. But try to find a way to automate every build process of your application. And it also, there are great tools out there, like Code Climate or Scrutinizer, which do static analysis. So they actually analyze your code you've written, and they give it a score based on design principles and how you should write codes in general, like on standards. And that score is really cool to release on legacy software, for example, because everything will be an F. It's just the way how it rolls. And then you can work on like giving you a measurable way to increase your code quality. Bring that F to an A, which is a goal you create for yourself, which is actually measurable. It's, in my opinion, very nice about it. Also, when you're working in this mainly related to legacy software again, it's if you're working in these code bases, don't think about your favorite framework. It's obviously very fun to work in stuff like Laravel or like React, Redux, and those kind of things. But the reality is that you're not going to be able to fully port it over to a framework like that. And if you can do it, then you probably are losing a lot of time, because they tend to be kind of opinionated, and you should not. Your code is probably already opinionated, so matching these opinions is kind of a waste of time, in my opinion. So, okay, now we have this code mindset thing out of the way. Oh, damn. Now we have this general mindset out of the way. Let's actually look at some real good things you should do in code, like some code hygiene stuff. Something I'm really into is it's also something that Uncle Bob, that's Martin. It's a famous Java programmer. He's written a few books about it. You can read like a few of them, but don't bother because they're not so interesting. One of his key things is like try and keep your classes and methods as small as possible. That way you can reuse a lot of code much better. And it's also easier to test in these things. So that's something if you walk away with one idea, it's probably this one. Just try and keep all your code bases. Don't go for 700 line files. Try to stick to like 30 line files. Is that possible? Of course it is. Just split it up. If you do your commits and pull requests, try to keep them also as small as possible. And also try and tell a story with your commits. The idea here is that once your code is in review, the person who is reviewing it can just follow along with your commit messages and see your entire thought process. That way they can analyze it and try to like find find your thought process through this story, and maybe see if you're missing obvious things or obvious flaws, which is really easy. Plus, it also gives you a great way to roll back some code and revisit some code. Code reviews. Code reviews is something that is, in my opinion, very obvious, but in reality has taught me that not a lot of companies do these things. So the idea here is that every pull request has to be reviewed by some other person, at least some other person. And give their opinion about it. It's a great way to introduce mentorship in your application. So people with more seniority or more knowledge about the domain or application can teach more junior, more people who are new to the project about how the things are working, and it's a very easy way to mentor some people there. So it's also not something that needs to be done from senior to junior. It can also be between two juniors, or a junior can review senior code, obviously, because juniors who are new to the project often know things or have seen things that seniors maybe take for granted or haven't seen at all. So there's a lot of knowledge in a company that's just going to waste. So try and pair these people up, which is obviously also a thing with pair programming. This is even more rare, I've seen in project teams. The idea here is that you're just sitting with two people, or maybe more if you're into mob programming, but try to stick to pair programming here. is that two people at the same time are working at one project. In a student environment, this is pretty obvious. Like when I used to study here, we did it all the time. In a company, I've barely ever seen it when you're not imposing it yourself. So try and work together on issues. You can learn a lot of things and you're going to cover a lot more bases. Managers tend to not like it because it's two people who are doing the same project, which is a billable nightmare. You're kind of like slicing your pie in half here. But that's really not true because the sum of its parts are more than its equal at this point. There's a lot more value because you're doing your code review, which is obviously another thing, at the same time. So it has a lot of value and you have a lot of mentorship between people. So it's a really valuable thing. So, okay, enough introduction about all these things. So how do we actually get started with trying to get a project that isn't really up to snuff back on its basis? You might be kind of amazed about the things that are out there. Some projects are in a bad shape, but this is a main, very broad action plan on how to actually get started on getting these things back together. So, first things first is your builds, gits, and deploys. I mentioned it before, try to automate everything. Well, you need to set it up first. Because almost all of these legacy or not very solidly built applications tend to not have these things. Git might be an obvious thing, but you would be amazed how many applications run without Git, for example. So yeah, try to make an environment where you can fail easily. The way you can, the reason why you want to fail easily is that you can try out new things. So try and make it so if you fail, that you can revert to a working stage as soon as possible. I'm talking about minutes here and not hours, obviously. Next up, this is in front-end. In the front-end environment, a very obvious thing. A debug tool. You have the Chrome web tools, which are pretty amazing, I think. Or like your Firefox web tools, I don't think, is that a thing? That's a thing. So these things are extremely amazing. Use them, obviously. Try to master them as good as you can. In backend environments, these things aren't really, of course they are there, but you need to set them up first and you need to configure them. So if you ever dive into backend code, one of the first things you need to do is actually set those things up, because as you know from your Chrome web tools or Firefox web tools, those things are really, really, really nice. This one might be a bit controversial. I know a lot of people adore things like Sublime and VS Code and Atom and whatever the new flavor of text editor is these days. And that's fine, obviously, really, that's fine. If you feel like VS Code and Sublime is working perfectly for you, okay. But if you're going into like enterprise software, okay, sure, you do your thing, you do you. But it tends to be a bit easier if you actually use EDA stuff, like where you have like decent auto-completion, click-throughs, automatic test running and all those things. I know you can set them up in Sublime and Atom and all these things, but still, why go for anything less? There are obviously people out there who use Vim. Cool. Okay, cool. Do Vim. If you do Vim, you probably know how to work Vim. So yeah, I don't have any suggestions there. You do Vim. One of the main down-to-earth things to start on these refactors and rebasing is you start off with end-to-end tests. So you write tests that automate. Again, automation is really important to automate your you clicking through the entire application and testing your results at the end. So that's really important. This is obviously not the fun part about refactoring stuff. So you're going to spend like at least a couple of weeks just writing tests. That's everything you're going to do. This is kind of also a nice moment to sit together with a domain expert someone who's really knowledgeable about the application you're building, and just ticking off all the boxes. What happens when I add a new customer? What happens when I add 50 customers? What happens when I delete 50 customers and then add 50 customers? All those things, and try to make all these stories into tests again. This is kind of a bit behavior-driven design. If you're into that, it's a fancy word to throw around. That's this thing. So, and then this is kind of one of the arguably, I think it's a very nice approach. There are a lot of different approaches about it, but I think this is the way to refactor old code. It's work outside in. Let me demonstrate. This is code. As you see, it's not happy code, but it's going to be happy code soon. So, as we said, we try to make end-to-end tests first. Okay, cool. So we know what needs to happen. And then we can write our own new, cool, shiny code around it. Nothing is breaking, because our end-to-end tests are there to check it. And our new code, which are like controllers, like checking the way how, like this is all business code. Like actually the code that does the hard things, like calculating invoices or calculating rental stuff. And this is more like a new rental has been made and send it through to the old code. Now, there's a big problem here. And that big problem is that my clicker don't work. Yeah, okay. That the new code has a hard time talking to the old code. Obviously, you can like interweave them, but a lot of people do. But then the big problem is that your new code is going to be very ugly and will be kind of like your old code. So you're actually making more old code, which is not a good thing. So how do we solve this problem? I'm going to switch to code now. So this is PHP code. I know most of you might not be so familiar with PHP code. So let me give a quick rundown here. We start with 1 million lines of code. That's how legacy software works. And we end with 1 million lines of code. So that gives you kind of an idea. What we're doing here is, check out my laser. We're making a connection to MySQL. That's a database. We check if there's an issue with that connection. Then we die, because that's what software does. It dies. And we add some new things to a table. We make the connection. We actually execute it, and we close that connection. If you're not familiar with backend code, this is ugly code. This is old school code. This is not something we do anymore. So how do we go and try and get this code out of there? So we're going to do something called an anti-corruption layer, which is a fancy word of saying a transition layer between those things. So actually, this thing, like with this thing, we're going to make that. So this is what we're making, and this is a static function, which is obviously not an object. You can like connect to it from the entire application without initialization it. So here we just create that add-cat static function, which gets out of the container our new shiny code. So the container is this piece of code that lives throughout your entire application. And there, from that repository, we're just going to call the new cat, which is just a classic repository that does, in this case, Doctrine stuff. Doctrine is a newer way to connect to databases. Newer, I say that because it's been around for a few years now. But it's a more object relational mapping way to interact with the database, which has a lot of nice things built in it, which does automatically connection checking and serializing your code, for example. So that's the way we want to try and build up our software. As you can see, this is the old code we had with the connection stuff in it. And this is the code we are currently making now, which is just one line to connect to our new code, to that transition layer for a new code, which is, I think, pretty nice. And as you can see, those million lines of code above and below there, they can do the same thing. Like we just go, next time we touch a feature or a bug, we try and refactor it the same way as we just did. We try to take a piece of code, rewrite it in a new way, make a transition layer between them, and reference it in our old code. And once those million lines of code slim down to like 5 lines of code, then you can just like take that out and you have your new code base. That's as easy as it is actually. So that's the general raw approach of how to manage these things. So, sorry about the brightness. So we've written the new code. Obviously we're now going to like slam heaps of tests to it, because testing code is obviously the way to go. Traditionally, you would go around this in a test-driven way. So the idea here is that you write your tests first, and then make those failing tests, because they fail, because you haven't written any any code yet, make them pass. So just write the code you need to make your test pass, which is the way we like to approach it in the back-end way. I don't know if that's a common thing in front-end stuff. That's interaction now. So yeah, that's basically the idea here. This is a buzzword. I like buzzwords. Microservices. A lot of people worked with microservices before? Yeah? So everybody loves microservices, right? Until you actually have to implement them. The thing is, microservices, so the big idea here is that you take code, pieces of code for your big application, and try to split it up on different servers and like make interaction between them, which sounds amazing because you can just scale up different parts of your code on different servers and make this like really high availability and other stuff like that. Obviously never ever going to be called again, or maybe a few times, otherwise you would just throw it away. But scale that down, and then you have this in theory, a beautiful piece of environment where you can just like load balance everything. The big problem here is that you need to load balance everything, obviously, and somebody has to do that. And my server skills are pretty lacking, to say the least. And to actually find people that can set up things like that, it can be kind of tricky, because there's a lot of intricate and fine tuning need to be done there. So it's kind of hard to find these people. And also, when you need to make them fully separate from each other, which is kind of a hard thing to do as well, also code-wise. You need to have an entire different way of approach for making microservices work with each other. So my great advice here is, if you think you're up to it, and obviously every company in the world thinks they're up to it, but like evaluate it first, try and make it work on a small scale before you roll it out on your big application. That's the idea here, basically. So just don't jump directly into microservices. Microservices can be amazing, especially in legacy code. It can really be amazing if you do it right. And I've seen it work a few times, but not always. So try and be a bit careful about those things. So we did the basic things about the code styling and refactoring and stuff, but now we're going to throw another buzzword at it, DDD, Design-Driven Development, which is this huge buzzword in backend development at the moment. But we're not going to go too hog wild here. Yeah, this sounds complicated, but it's actually not. It's a new way of thinking. It's not new. It's invented in the 70s, but it's a different way of approaching your file structures. Clickety. Yeah. So this is traditionally how a lot of backend applications look like. This could perfectly be transposed from a Laravel application, for example. So here you have your controllers together, your models together, your validators together, and your transformers together. The DDD kind of way is to split these things up, to make it based on your domain. That's a very easy way to think about it. Just think about everything that incorporates users, we're going to put behind the user flag. Everything that incorporates posts, its own little domain. The cool thing here is that you can, in theory, take a piece, for example, post, and drop it into a new project, and everything should work. Obviously, that won't happen, but still, it's nice to think about it, right? Which makes also refactoring a lot easier, because you know everything that touches posts will be there in that map, in that namespace. You guys have namespaces? Does JavaScript have namespace? Okay, so yeah. Yeah, that's cool. And you might think, well, okay, what about like a post that interacts with the user, like where I'm going to put that one? Well, if you have a class that interacts with both your user and your post, then your class is way too big. And it doesn't solve a single thing. So try to refactor it again. Try and make your classes as small as possible, so it only does one thing and does it really well. So that's the idea. Another great thing I love about the DDD way is value objects. It's really amazing, I think. So here, another bit of PHP code. I'm going to walk you through it. You're going to create a class. You guys have classes, right? Where you set an amount of cats with your ID and your amount. Okay, cool, easy as that. This is the user controller. Controller is the thing that like sends your code around. And here we're going to call in the update function here. We're going to call these values. Okay, what was first and what was second? We have an amount and we have an ID. Was it the first parameter, the ID, or the second one? Who can remember? Was it? I don't even remember myself. So the big problem here is that an ID, in some cases, is an integer, and an amount is also an integer. So you can be kind of wrong here. Obviously, you have, if you use an ID, it says like what's the amount and what's the ID. But still, you want to make this a bit more bulletproof, right? And that's where value objects come in. Here we created a class around a user ID, which sounds like really an insane thing to do. Why wrap an ID inside of a class? What's the ID here? The ID here. So this is what a user ID class would look like. It has a few cool things about it. So here you have the value, which just returns your integer. But also, once you create a user ID here in your constructor, it does a check. You can just build in validation inside of your primitive types, which is really cool because now you can't create an invalid ID. You can't create an ID null or with something else in it. That's you just set it up, which is really cool because every time you see a user ID passed around in your system, you can be entirely 100% sure that that ID is a valid ID. Also, you can add functionality to it. So you can, for example, get it as a UUID. UUID is something I didn't put in the slides, but it's something really that's insanely handy. Try and always define your ID, not always, but most of the times try and define your IDs as UUIDs, which is like a unique string, which should be unique for everywhere, to tie your tables and just your general classes together, which is really cool. Another thing here, this is immutability. Immutability is in the backend world another big buzzword. Everybody loves it. Nobody knows what it actually is. The thing about immutability is that, for example, if you have, instead of a user ID, a user, for example, that you can't use getters and can't use setters. So every time you want to create a new user, you need to fill in every field, and you can't remove fields anymore. That way, it's always a solid form of a user, which is always a fully correct version of that user. So, okay, you've done all these things now. You're a legacy code developer now. Cool, cool stuff. Obviously, there's more to it. this is just a basic survival guide. You're dropped in a project, how I'm going to go around these things. There's a lot more to this. I'm not going to be able to cover it. There's been books about this stuff. And also, every application you're going to touch will be different. There will be different challenges. There will be different problems. The main advice here is just talk with the people who are in your team or in your environment, and like try and make your decisions as informed as possible, and try and keep an ear out to what's happening in the world. Even if you're on legacy code, on old code bases, still try and keep in mind what's happening in the new world with the new code and the new JavaScript stuff that comes out every 15 minutes. And then try and see if you can take things from that and try and fit it in your code. So obviously, you're going to see some funky things, obviously. If you're going to touch code that's been around for years, then yeah, it has years worth of code in it. So you're going to see some mistakes, obviously. But that's the fun thing about it. Just well, try and analyze it. And you can blog about it or do a talk about it or something. Try and loop back to community and stuff. Also, try and understand why things are done in the way they are. If you can go to an application, a class, for example, and you see some insanely stupid code being written, well, that code might have been smart a few years ago or a few months ago. That might actually be a great solution about going through a problem. But you're missing maybe some product knowledge about why it's there. So it's also really, really nice to try and understand why it was there in the first place and try and keep your value out of it. So I guess I'm going to leave you here, but there's more to learn, obviously. There are a few things I really liked when I just started in legacy code bases. So there's this book, Modernizing Legacy Applications, written by PM Jones. It's a PHP book, but it's really applicable to all languages. PM Jones, you might not know him, but he's kind of a controversial person. I don't really support his views on the world, but I support his views on code, so that's something, I guess. Then there is like a book where you can murder someone with, called Working Efficiently with Legacy Code by Michael Feathers. It's like, yeah. Try and read that. And then there's, if you work in PHP, there's always these, I assume it's the same in front-end land, there's always these decoupled packages. So try and keep an eye out for decoupled packages and try and include them in your applications. So yeah, thanks.